Now would you look at that, I got a new present. And it's a bloody nice present as well. Or is it? Considering that I got this sent to me for free, I'm certainly not in a position to complain. Nice! Nice salmon color. I like this color, the color scheme. I hope that the printer inside also has this salmon color scheme. No, it hasn't. Okay, first disappointment. Yeah, you can probably guess where this is going. I of course, as always, try my best to be as objective and fair as possible with this review, and I'll even end up scouring YouTube for a second and third opinion and asking friends for a fourth and a fifth opinion, just to make sure that I don't end up burning the wrong bridges. But before I give out too many spoilers, let's take a look at what a past version of myself had to say regarding the Longer LK5 Pro 3D FDM 3D printer. Okay, I'm going to put this chair away. The first thing I see is the crazy amount of filaments. So this 3D printer is going to be a bed slinger, and I'm not the biggest fan of bed slingers. In fact, I don't really like them at all. But this is going to be unbiased, or at least I want it to be unbiased. So let's just take a look at what we've got here. The space here is way too little. I have to reorganize. First issue with step 1 and 2. It states that these screw holes have to be on the left when everything is mounted, yet these screw holes cannot be on the left. Let me set up the camera a little bit differently. You can't see anything. Now what is this? Strain relief bracket. No. Okay, strain relief bracket is not mentioned, so where am I supposed to put this strain relief bracket? I don't know. This means that I have to use common sense or what? They also don't say anything about tensioning the wheels, which you definitely have to do because this is super loose. I mean, I know that I have to do it and I know how to do it, but it's not mentioned in the manual, which is quite crucial because this is unacceptable as it is right now. I want you to hold that thought for a second. So, as I said, I ended up taking the printer to the lab of my university to get some more opinions. Dokumentation war erstmal nicht so gut, bis ich dann irgendwann festgestellt habe, dass ich einfach ein Vollidiot war und auf der SD-Karte einfach Videos und so drauf sind, wie man das Teil zu benutzen hat.
Aber das muss man wissen eigentlich, muss man auch sagen.
Genau, das stand halt nirgendwo. So the information on the SD card is indeed better, but there's still no information on how to tension the roller wheels. And while I'm at it, the official language of Germany is German, not English. I kind of find it common sense to have the manual of a product in the language of the country it's being sent to. Okay, it's the next day. Yesterday I put all the connectors where they belong. Super easy, super straightforward. And I think I figured out where this strain relief or supposed strain relief is supposed to be. And it's probably right here at the build plate. As this moves back and forth, this cable might fatigue and cause higher resistance within this connector or within the cable. And higher resistance with a lot of power going through this cable means... Unfortunately, I'll have to take the bed off for this, but this will be also a great opportunity for me to fix this wobbly bed. Oh, one thing I'm also just noticing is that the heated bed is not insulated from the bottom side. Only this part seems to be insulated, which is probably where the thermistor is underneath. It would probably make a lot of sense to insulate the entire bottom part of the heated bed, because although we have 24 volts going through the heated bed, which is, well, better than 12 volts with the same amperage, you still don't have a lot of power going through here. So it will probably take a while to heat up, and insulating this will probably increase that time by quite a bit. And on top of that, insulating the bottom part will help with temperature consistency. So if there's a slight gust of wind blowing across this build plate, it won't cool off that quickly. Like this or like this. I'm not sure. But this definitely seems to be the right place. Oh, but first let me fix this mess. Okay, now it's good. Now I can turn the wheels and the bed will turn as well. This is exactly how it's supposed to be. Yes, this is definitely how it's supposed to be. Make sure to give it some slack and then tighten it up. I just wanted to fix the tension on these free spinning rollers, and then I realized that depending on where the gantry is, they will either spin or not spin. So that means that these vertical beams are not perfectly parallel to each other. But we should be able to easily fix this by just loosening these screws and changing the distance. I'll probably have to loosen these on the bottom as well. I just realized. Okay, this is a bit more involved than I thought it would be. Oh boy. Now I must say I don't really blame them for this. It's just a general issue that you get when you're working with these aluminum extrusions and you want to pre-assemble parts of it, but you can't pre-assemble everything. Then it's just really hard because it has to be assembled like it is right now, and then you can adjust all the parts. But if you pre-assemble half of it and then expect the user to assemble it fully, which makes sense if you want to ship it from China or, you know, ship it all around the world, then you have to pack it small. So, you know, this is just a general problem that you have when you're working with these aluminum extrusions. Fixed. The next thing that I noticed is that this Z end stop is being triggered by the Z roller wheel, which in and of itself is already bad form, but it's also triggered at the wrong place. It should be triggered right up here at the maximum lever point and not somewhere here in the center. And this just reduces Z resolution or the trigger resolution, which I guess this works good enough. And for simplicity's sake, they probably just left it like this, but it's bad form and I don't like it. And speaking of bad form, this belt drive gear is mounted way too far away from the motor. This distance creates a very large moment arm on the shaft of the motor and on the bearings inside, which will quickly kill the bearings and the shaft if you tension this belt correctly. If you look at it from this side, you can even see how far inwards the end of the motor shaft is in relation to this drive gear. See, this is how it's supposed to be. I switched the belt drive gear around so that way the belt will run closer to the motor itself, which then creates a smaller moment arm on the motor and on the shaft. But of course I can't keep it this way currently as it is, because I would have to shift the entire motor assembly to the left, which is easier said than done because I would lose access to this, which you can't see. There's a screw right here which screws into the aluminum extrusion. But there are so many different mounting points on these aluminum extrusions that you don't have to use this specific hole to mount a screw to. But for now, unfortunately, I'll have to revert. I'm being quite nitpicky here, and there are a few reasons for that. Firstly, each of these small things would have taken maybe an hour to get fixed during the design phase, and that at no additional production cost. And secondly, it feels to me like I'm grading the homework of someone else, which has been changed just enough by putting it on stilts in the hope that no one would notice. So I think it's fair to hold them to a higher standard because they didn't have to reinvent the wheel. Tom recently made a great video about this exact topic, which you can check out by clicking the I up here. I think it's a very important topic and I'm happy to see it finally gain some steam. So if you're interested, I put together a list of other channels which have recently talked about the topic of 3D printer clones. You can find that list in the description of this video. But unfortunately, there are some more nitpicky things and also some less nitpicky things that I just can't leave uncommented. So let's move on. So on the other side of the y-axis we have this pulley, and let me show you what it looks like. These are just two flanged bearings next to each other, which is perfectly fine if you want to run the back of the belt on them. But these things exist and they probably cost even less than these two bearings. Why not use a tooth bearing? These are more expensive than these, and on top of that, the teeth of these belts, which look like this, are not meant to be run on a flat bearing surface. And the same thing is unfortunately also true for the x-axis pulley, where it's flat as opposed to the toothed pulley. While I'm already talking about the x-axis, I want to show you this belt. So over here you can see a gap, and over here there's no gap. And if I move the x-axis over, you can see how the angle increases and decreases again. And this doesn't seem like a big issue, but there are two reasons why it is, so let me show you. The first reason is that this belt does have enough space inside and outside of this aluminum extrusion, but there's not enough space for the width of the belt when it crosses from inside the extrusion to outside the extrusion. So it gets kind of mangled up when it crosses. But okay, so far this is of course not that big of a deal because it might just wear the belt out a bit quicker and it's just slightly annoying. But let me show you what happens all the way over here. So watch closely what happens with the belt when I move the x-axis gantry. There, you see, it releases and now it hits the end stop. So it comes all the way out of the aluminum profile, not that big of a deal, kind of nice, but then when I move back, see what happens? And it basically stays all the way this way up until like 25 centimeters out. So this snapping action might of course be visible in the print, but also since it runs for such a long time on these very sharp edges of the aluminum profiles, it wears down the teeth really quickly. The second reason why this angled belt is problematic requires a bit of maths.
2 + 2 is 4, -1, that's 3, quick maths.
I wrote this MATLAB script to simulate the movement of the extruder along the x-axis. Yes, that is supposed to be an extruder. I know it's not particularly beautiful, but at least the science behind it is. Well, kinda. It's just Pythagoras, to be honest.
Quick maths.
So the extruder is mounted on the X carriage, which is represented by this thick blue line. The thin blue lines are the belt, which loops around 2 pulleys represented as black circles. Now let's overlay a second extruder, this time with the belt mounted parallel to itself. If you're watching this on your phone, this probably looks perfectly fine, in which case I'd kindly ask you to finish wiping and watch this clip again on a bigger screen. Ah, wait, there's no need to rush your business. I exported this clip in 8K, so I can just zoom endlessly. Quasi-endlessly, of course. After a 300mm travel, this is where the printer thinks that the extruder is, and this is where it actually is. Let's go back again and plot the difference between both positions as a function over the travel distance, representing the induced error. Now that's a difference of more than 0.5 millimeter, and I know what you're thinking. 0.5 millimeter, that's basically nothing. So who cares? Well, if the printed parts have to fit together, this error has to be accounted for, else the parts simply won't fit.
Well, I suggest you gentlemen invent a way to put a square peg in a round hole. Rapidly.
And what's even worse is that the error is non-linear, so it differs greatly depending on the size of the parts that are being printed. And all that trouble just because the engineer either didn't know about Pythagoras or because he or she had a lazy day. This is, for example, the Orta LaserMaster 2 Pro, which I reviewed recently. With this design, the belt is attached in a slightly different way, which allows for the belt to be pushed into the aluminum profile, making the angles much better. It's still not perfect, but as far as I know, it's the best solution there is for these types of V-slot rails. Before I finally start this printer up, I want to take a quick look at the electronics. So the power supply seems to be a 24 volt, 360 watt Changliang power supply, and the connections are all really good, properly crimped, really nice in place, and the cables as well are nice and sturdy. Everything is super well done. I've seen much worse. So just from a safety standpoint, I'd say this is already perfect. And then with this cover on top, there's basically no way for anyone to accidentally touch this. The power supply is also directly mounted to the aluminum frame, which means that the entire frame is properly grounded as well. So overall, no issues here. The mainboard seems to be a custom one. It says LGT Kit version 1.0. Now, unfortunately, it's an 8-bit board. I'm not really opposed to that. My own 3D printer, which I built a long time ago, also is an 8-bit board. And for anything that I want to do with it, it works perfectly fine. And I guess that's the same with this board as well. But we'll have to see. The only thing that I would say is maybe missing on here is another spot for another stepper motor driver. But other than that, it does have everything. They put in the effort to actually create something like this. And they used proper parts, which I really like to see. And with proper parts, I mean nice beefy connectors over there for the power lines. Then for all the not so power hungry lines, they used JST connectors, which I very much prefer over the DuPont connectors, of course. And then they also used proper stepper drivers. These are really nice to see. These are 2208s. They are super silent. The only stepper driver that isn't super high end is the one that's down there. I think this is for the extruder motor, so you probably won't even hear this one. But of course, I'll report back on that. Yes, you can indeed barely hear it, but unfortunately not for the reason that I was expecting. Now let's just finally start this thing up after 2 full days of filming and hope that this doesn't explode. That's pretty loud. Okay. That's a bit louder than I expected, to be honest. Screen. Yeah, screen is working. Now you can feel that it's a resistive touchscreen and not a capacitive. But yeah, it's nice. Really nice. I like it. Okay, but Let's get back to the sound. Aren't these printers meant to be used at home? If you have this sound on for 10 minutes, maybe 20 minutes, I guess that's fine, that's a bit annoying, but this is a printer with a print size of 300 by 300 by 400 in height. So it will probably take like 4 days to fill this thing up. And that means that you would have this sound for 4 days non-stop in your house. I don't know what to say. I think this is absolutely unacceptable. I'm also kind of baffled that they advertise their super silent steppers, which, I mean, to be clear, these steppers are super silent. You can't hear anything, which is really nice. But part of the reason why you can't hear the steppers at all is because this printer is so fucking loud. So I wanted to know what other reviewers had to say regarding the fan noise. This is from the 3D print creator.
When in use, you will notice that this printer makes almost no noise at all, except for the cooling fan, but that's something that you will hear on every printer. I would say that there is no reason to isolate the printer from people that can't handle noisy equipment because it's very silent.
And this is what Angus from Maker's Muse had to say.
And thanks to those silent stepper drivers, this machine is really quiet. It's actually pretty much silent. It's one of those machines that is so quiet you forget it's on if it wasn't for vibrations passing through the surface that it sits on. The stilted design makes it a little challenging, but if you put this machine on a concrete tile or foam mat, all you'll hear is fan noise.
So with that, I see two options as to what is going on here. Either I got a bad unit, which is more noisy than the other ones out there, or I have my personal standards set way too high. Let's start with number one. I sent a clip of the noise to Longer, the manufacturer, to check if I had gotten a bad unit. And their answer was, which I'm paraphrasing, that there's nothing wrong with it and that I could print this third-party power supply cover to reduce the noise, which was designed for the Creality Ender 3, which is their competitor. Okay, clearly there's no bad blood between those two companies. This turned out pretty well. There's some curling here and some pillowing right here, which indicates that the cooling fan is under spec. A blower fan would yield better results, but those are much louder, which coincidentally I've just learned that I'm quite sensitive to. So I appreciate the trade-off, but you, however, might not. There's also quite some stringing, but I don't blame them for that because my filament is quite old and I think it's just gotten wet and that's why there's this amount of stringing. Now let's try to take this off. I've heard on the internet that these glass plates, when they're cool, and this is totally cool, that it's super easy to release. Some say it releases too easily because when the power goes out it will just release like that and you won't be able to proceed with the print. But from my testing and from what I can tell right now, this is firmly stuck in place. And I do quite like these ceramic coated glass plates because they're just so easy to use. They're very heavy, so the moving mass is quite high, but yeah, they're much easier to use. Now for the supports, let's see. So here the supports released quite easily. Let's see how this releases. Yeah, I can't get it off. Yeah, this is a bit of a shit show, but of course this is all configurable in the slicer. Well, it's passable. It's okay, I guess. It doesn't look too great, but these curvatures are really hard to print, especially with low cooling performance. At least the parts did stick well and the supports did release, although it wasn't very easy, but they did release, and overall, yeah, it does look okay. Interesting design decision, however, to increase air turbulence by putting holes in the walls. It seems a bit counterproductive for a part that is supposed to reduce noise. I'm exaggerating, of course. Well, a little bit at least. This is the control noise test I'm recording with the Rode Video Micro into my iPhone. And now with the fan silencer mounted. The cover doesn't really help with overall loudness, but I find the shifted frequency with the cover slightly more pleasant. The main noisemaker, however, is this fan of the electronics compartment, which I found didn't get dampened at all by the cover. Of course, there are plenty of ways to properly fix the noise issue. I just don't think that it should be up to the consumer to do so, especially if this is what's being advertised. And just like the fan for the electronics compartment, this cold end cooling fan is also always on. Why? Just have it turn on once the nozzle is warm. Sure, it would require 2 additional MOSFETs to control the 24-volt input voltage, but those literally cost pennies. And same thing with a power supply whose fan doesn't have to spin if its internals are already cool. Both the stamped note on its cover plate and the internal logic is already there. All it takes is this jumper wire to be replaced with a thermal switch, so the fan would only turn on once the power supply gets hot. But with everyone raving about how silent this printer is, I'm starting to question my own judgment, so I'm really curious as to what you're thinking. Is this normal? Should it be normal? Leave it in the comments below. This video has already been going on for way too long and I didn't even touch on the extruder assembly, so I'll try to make it quick. These couplings will chew up the Bowden tube, increasing play and causing nasty stringing issues, which are very hard to troubleshoot if you don't know what you're looking for. This brass hopped gear will soon look like this, even if only PLA is used, which causes nasty under-extrusion issues, which are again very hard to troubleshoot. And if the brass gear already looks like that, you can imagine how the filament will chew up this plastic filament entry point. The Bowden tube is advertised as being a, quote, high-temperature resistant Teflon tube. Apart from Teflon being a trademark name by DuPont, these PTFE tubes should never, there I said it, they should never enter the hot zone of a 3D printer nozzle, no matter what kind of magic sauce they put in there. Here's a list of reasons why. Another thing I just realized is that this red stuff there and there, it's actually not thermal compound, this is silicone. I've never seen something like this. Silicone is a great thermal insulator, and I guess you can see why this is an issue. This block is where the heat gets transferred into, and this nozzle is where the heat has to go. I talked with Andrew Sink about the LK5 Pro because he has recently reviewed it as well, and he has a lot of experience with these kinds of printers, so he definitely knows what he's talking about. And as a side note, his icing game is fire. Anyway, so I was curious because his review was much more positive than mine, to which he brought up an important point, which is, of course, its price. Quote, the printer is designed to solve the problem of providing a large volume at a low cost, so the components are generally inexpensive and engineering time is not spent on these subsystems. With a price tag of around $300 to $400, this printer is firmly located in the lowest price bracket. So, and I quote, it's expected that corners will be cut throughout the production process. And to be honest, I totally agree with this assessment. Corners were cut, which I should have expected. I guess this is just an unfortunate case of you get what you pay for. What rubs me the wrong way, however, is that most of my points of criticism would have been free to implement. Here's a little slideshow of all of my points and what it would have cost for Longer to implement something better. You'll see that most of it would have been basically free, and that's exactly the point that I'm trying to make. Of course, this printer is in the lowest price bracket for its size. I respect that, and my criticism is not about that. It's mainly the fact that corners were cut where there was no reason for them to be cut in the first place, for which the end user will end up paying the price, which shouldn't have had to be paid in the first place. I know that I'll get criticized for not printing until something fails in order to prove my points. That's a valid argument, but this is the best I can currently do. I'm simply not going to pump 10 kilograms of plastic through this printer and live with a vacuum cleaner next to my desk for a few weeks just to be able to prove a point. If YouTube was my job and I had a separate 3D printing room available, I wouldn't even hesitate doing so, but that's unfortunately not the case. This is probably one of those videos where it's especially important to check out multiple opinions, so I've made a list of other reviews which you can find in the description. With that said, I want to give a huge thanks to Pierre and Jamison who found and supported me on Patreon without me ever even mentioning it. A big thanks also goes out to Longer, the manufacturer, and my contacts at Z-BANX for sending this printer out to me. I really hope that Longer takes my criticism to heart and creates a banger next time. Now I'll leave you with some clips that I filmed at my university. Thanks for watching, and I hope to see you very soon. Goodbye.
Nee, ich finde es sehr stabil auch. Ein gutes Material, das ist kein Kunststoff auf jeden Fall mal.
Ja, die Stangen, die gefallen mir ehrlich gesagt auch ziemlich gut.
Und das, was gefällt mir halt einfach generell nicht sowas, weil da müssen wir andere Lösungen eigentlich für sowas her als sowas.
Ja, es ist halt simpel, ne?
Ja, es geht nicht um simpel, sondern es geht einfach, dass ich hier diese Dinger habe. Ja. Und für 200, 300 Euro, also 270 war es glaube ich irgendwie so, ist es doch vollkommen in Ordnung. Gut. Ich will nur die Druckqualität sehen, ja. Ich habe einen hohen Anspruch, weil ich halt den Anspruch von denen hier kenne. Einfach sieht an der Rundung hier, dazu mal so ein bisschen zu weich war, glaube ich. Ich will mal
Das ist ein Kritikpunkt, den viele andere hatten, dass die Kühlung nicht ausreicht.
genau.
Ich kann mir vorstellen, dass es insbesondere hier an der rechten Seite noch okay ist und dann an der linken Seite, weil da halt keine Kühlung ist,
Ja.
dass es dort dann schlecht ist.
Das vielleicht auch. Jetzt können wir ändern, wenn wir die bessere Kühlung haben. Weil die sieht wirklich besser aus verglichen zu der, ja. Okay. Hat gekühlt. Aber immer, Kühlung ist da.
Wieso 200 Grad? Wir haben zum Beispiel, wir drucken alle auf 210 Grad.
Die drucken aber schneller. Und außerdem ist die Kühlung bei dem leider sehr schlecht. Also da siehst du, rechts ist der Lüfter,
Ja, ja, der
der
ist
Teilelüfter und der startet erstens nur von rechts, zweitens ist es so ein Radiallüfter, die halt kaum einen Staudruck erzeugen können. Und ja, deswegen habe ich es jetzt eingestellt, dass er sogar während dem Drucken auf 190 Grad runtergeht. Und nur jetzt für die erste Schicht, damit es besser klebt, 200 Grad.
Ich muss fragen, wie machen wir die SD-Karte rein oder wie machen wir das Programm rein?
Such mal, wo kommt die SD-Karte rein? Es ist eine SD-Karte.
Da hinten.
Ja.
Warum da hinten?
Ja.
Warum?
Ja, weil da halt das Board ist. Und ich schätze mal, das hätte halt nochmal 30 Cent mehr gekostet, wenn man so einen SD-Extender bis hier vor verlegt hätte.
Ja, aber also das würde ich nicht.
Weil das habe ich ja hier gemacht. Da habe ich so einen SD-Extender genommen,
Ja.
weil das Board ist da drin und dann kann. Nee, warte, das geht. Dann geht es, kann das hier rüber und ja.
Ja, ist eigentlich okay, kann man auch ein bisschen bemängeln, finde ich.
Das Display sieht natürlich nicht schlecht
Das
aus.
Display gefällt mir echt gut. Das ist Touch.
Das hat eine schöne Auflösung, oder?
Ja.
Ich sag, das fällt gleich runter. Ey, das gibt's doch nicht. Ey, das ist doch nicht. Oh, das gibt's doch nicht. Hey, ich krieg das nicht runter, einfach so. Ja, ich muss es runterhauen. Ey, wo ist das Loch? Ich finde das Loch nicht. Ah, da. Ups. So, jetzt habe ich es drin. Mal gucken. Und jetzt mache ich einfach Low. Jesus. Und wie lange soll ich denn hier warten?
Jesus, ja.
Eieiei. Oh. Ah, ich mache nicht gelb rein, aber ich pink reinmachen wollte. Ich voll lol.
Ja, dann wechsel wieder.
Unload. Ist kaputt.
Finger weg. Ups.
Ups, ich brauche die Hups.